everybody. So we're going to work on the power rule now. And this is going to be section 3 of our Master Math Unit 8, it's Techniques of Differentiation. So we started with the constant rule and the single variable rule, and now we're moving on to the power rule. So let's read what it says. If n is a rational number, then the function x to the n is differentiable. Again, we're going to really worry about that differentiable a little bit later as we move through. And d of x, meaning the derivative of that function, equals n, which is the exponent, and then drop it one value up here. Okay, so what does this look like? So eventually, you will get to the point you can do this in your head very easily. But in the beginning, let's kind of do this slowly to make sure that we are catching everything. So when I take my derivative, I'm taking y prime of my function. So my 2 is going to pop down. And then I do 2 minus 1. So that's going to be 2x to the first power. Now, that's a line. So if I wanted to draw it like this, I would have something here. And it says, determine the derivatives and determine whether the x value for which the function is differentiable. Well, a straight line is going to be differentiable all the places. There's no place it can't be. So we're going to say differentiable everywhere. F of x equals x to the 6th. So again, we're going to be bringing that out front. So f prime of x equals 6 x to the 6 minus 1, which becomes 6x to the 5th. What does this look like? So this is an odd function, and we know that it's going to follow along something like that. There may be another bump in there somewhere, but an odd function with a positive value out front looks like this. There's not going to be a hole, there's no asymptotes, so this is going to be differentiable everywhere. So now we have s of t equals t to the 30th. S prime of t equals 30 t to the 29th. Again, odd function. Okay, it's got an odd exponent. We know it's going to look something like this, probably with a lot more bumps in it, but something similar. That's going to be the end constant or the end values going in opposite directions. Positive goes that way. So again, that's going to be differentiable everywhere. Okay, so now we get to a special situation we need to really pay attention to. First of all, never differentiate with a square root present. This is really x to the 1/2. Okay? So when I take this, I'm going to do y prime equals, the 1/2 comes in front, x, and then 1/2 minus 2 over 2. Well, why did I do 2 over 2? Well, 2 over 2 is 1, and I have to take down a whole 1, so I just changed it to 2 over 2 so you can see it better. So that's going to be y prime equals 1/2 x to the negative 1/2. Now, a lot of times I'm okay with it if you write it that way, but more often than not, you'll also see it change this way. This is a square root on the bottom, because that's what the negative means. Put it on the bottom, so it looks like that. Now, the next question is this differentiable everywhere? And the answer is no, because I can't have a 0 on the bottom. And when does that happen? Well, as soon as I hit 0. So it's differentiable when x is greater than 0. Now remember, we also can't do negative square roots either, but our bigger problem in this case was hitting the 0 first. Okay? So, let's again look at the directions. In general, we prefer to leave answers with positive exponents. That's why I moved this guy to the bottom. because it's a positive exponent when I put it in its place. So we see it like this, but we don't really want to have it that way. So remember, this really means x to the negative 1. So y prime equals negative 1x. Drop this 1. Remember, we're going to the left like that. We don't want to have a negative exponent, so I'm going to change this to negative 1 over x squared. Then I look at it. Where can this not work? I'm differentiable. I'm differentiable for everything. So I want to say differentiable. Well, let's just do not differentiable at x equals 0. Because I can put in a negative, that's fine, but I can't do it at the 0. That's the problem. Okay, this guy. So notice again, I'm just writing next door. So I have f prime of x equals negative 3x to the negative 4. Notice again how I keep writing that f prime of x. So there I go. Same answer. Not differentiable at x equals 0. Now, this is, of course, where it gets yucky. We have weird fractional exponents on the bottom. How bad could this possibly be? So I'm going to change this to be t to the negative 1/3. So remember, when the number's on the bottom, that is a root. So this is a third root. So s prime of t equals negative 1/3 t. And I'm going to do negative 1/3 minus 3/3, because that's 1 with a common denominator of 3. Okay? So this is s prime of t equals negative 1/3 t to the negative 4/3. So s prime of t equals negative 1 over 3 t to the 4/3. Now, the great news is no matter what number I put in here, if I talk about negatives, I'm going to be raising it to the 4th power to become positive. So I'll easily be able to take a cube root. And remember, if I take a cube root of a negative, that's fine too. So I can put in positives and negatives. What I can't do is still put in a 0. So I'm going to be not differentiable at t equals 0. Okay? Our next one. So what I'd like you to do is pause the video. I'd like you to try this on your own and then come back and see how you did. Okay, so we have y prime. And I'm just going to do x to the negative 3/4 over here. Kind of tiny because I kind of spread out my work. So negative 3/4 x, and this is minus a 4/4, so this is going to be negative 7/4. Negative 3 over 4, x to the 7/4. So in this situation, I need to be careful because I can put in an odd number, and if I raise it to the 7th, it's still odd, and I can't take an even root of a 7th number because it's imaginary. And I also can't take a 0 root because that'll make the bottom 0. So this time the answer will be differentiable at x is greater than 0. So you do need to pay attention to where it's differentiable. Okay, usually make a comment about it. Notice that we're always going to be writing with positive exponents. Sometimes I'm not too worried. You may see stuff with negatives, but traditionally we do keep things positive. If you get stuck, go back to what we were doing in Algebra 2 and Pre-Cal. What does the picture look like to help you out? Okay? And little small steps like that will really make a difference for you. All right. Best of luck.